In this video, we are going to classify signals as periodic and non-periodic. So first of all, let us see what are periodic signals. A simple definition of periodic signal is a signal is said to be periodic if it repeats after certain interval of time. And the time interval after which it repeats is called as the fundamental period of this signal. Therefore, a signal is said to be periodic if it repeats after certain interval of time, and in the equation form it can be represented as if x is our signal and if this signal is repeating after the interval capital T, then x of t plus capital T will be equal to x of t. So this is how we can represent the periodic signals. Now we know that sine, cosine, these signals are periodic. So in general we may get an example like if we have x of t equal to, let's say, 3 cos of omega t. In this case we are supposed to find out the time period of the signal. So from omega we can find out the time period as omega is 2 pi f. From this equation we will have value of omega. From this value of omega we can find out f, and from f we have the time as 1 by t. Therefore t will be 1 by f. So this will be our time period after which our signal repeats, and it is represented in seconds. Now secondly, we may have the signals like x of t equal to, let's say, 2 cos of omega 1 t plus 3 sine of omega 2 t. Now when we have combination of such kind of signals, in that case whenever we are going to prove that whether this signal is periodic or non-periodic, in this case from omega 1 we are going to find out f1, and from f1 we are going to find out the period of first part. Similarly, from the second case omega 2 we are going to find out f2, and from f2 we are going to find out t2, which is 1 upon f2. Here also t1 is 1 upon f1. Now from the given signal we have only omega 1 and omega 2, so we are obtaining t1 and t2. If we have more signals added with it, let's say there is one more component like 4 cos of omega 3t and so on, so in that case find out the time period for every component. So t1, t2, t3, t4 in this way. And now this signal, the combination of signal like cos plus sine, will be periodic if the ratio of t1 by t2, if we have more values like t2 by t3 and so on, t3 by t4, this ratio should be equal to ratio of integers. If this is ratio of integer, then we can say that given x of t is periodic. And now the period for such signals is calculated as the LCM of all the values. So here the period t for overall combination of this addition of sine and cos will be LCM of t1, t2 and so on. So there is one simple way to find out this LCM. Straight away you have t1 lambda 1 equal to t2 lambda 2 equal to t3 lambda 3 and so on. This will give you the time period t. Now in order to find out this equation, you may find out first lambda 1 by lambda 2, which will be equal to t2 by t1. From this representation you can find out value of lambda 1, you can find out value of lambda 2. So simply substitute this value of lambda 1 in this above equation, you will get the fundamental period t. So this is how we can classify the signals as periodic, but this representation is entirely for a CT signal. Now let us go with the discussion for discrete time signals. So now if we have a DT signal, how we are going to classify it as a periodic signal? See, the representation, the definition is again same. If the signal repeats after a certain interval of time, it is called as periodic signal, and it will be represented as x of n plus capital N is equal to x of n. So the signal is going to repeat after interval n. Now whenever we have this kind of equation and we are supposed to find out whether signal is periodic and non-periodic, in this case our equation will be of this kind: x of t equal to, let's say, 2 cos of omega t. Now here, whenever it is discrete signal, this representation will not be in terms of t. This representation will be x of n equal to 2 cos of omega n. So here we are using capital omega. From this capital omega, we are supposed to find out now 2 pi f. So we are supposed to find out f, and our f will be ratio of some values. So if this f is equal to k by n, and if this k by n is equal to ratio of integer, then we call it as periodic signal. So here from this omega equal to 2 pi f, we are going to find out f, and this f will be equal to k by n. So it will have some ratio, and if this k by n is equal to ratio of integer, then we are going to say that this signal is periodic and the period is given as n, and this unit of this n is samples per cycle. Similarly, if we have a signal, discrete signal of the kind x of n equal to 2 cos of ohm 1 into n plus 3 sine of ohm 2 into n. In this case, again we are going to find out ohm 1. From ohm 1 we are going to find out f1. So from f1 we will get k by n1. We have ohm 2 equal to 2 pi f. From this f2 we are again going to find out k by n2. And now if this n1 by n2 is equal to ratio of integer, or if there are more number of terms, then n1 by n2 divided by n2 by n3, if this ratio is equal to ratio of integer, then we say that this signal is periodic, and this period will be equal to LCM of n1, n2 and so on. So again here also, to find out period n, it is not t, it is n, which is LCM of n1, n2, n3 and so on. This n can be obtained using the equation what we have used in the CT form, which is lambda 1 by lambda 2 equal to t2 by t1. So here we can have it like lambda 1 by lambda 2 equal to n2 by n1, and find out the values of lambda and substitute it, and we get the LCM for n.